This is the homework for 377, 78, 79, and 81 A and B. For problem 377, you need to sketch and label the shape of your paper and write an expression that represents the perimeter. So here are the algebra tiles. We have an X, unit tile, Y tile, unit tile, and X tile. And remember that perimeter is the distance around the tiles. So it's the sum of the length of the sides. So here we have x plus 1 plus y plus 1 plus x plus 1 plus x plus 1 plus y plus 1 plus x plus 1. And you add all of those up and you'll get the perimeter. But in order to add them up, you can only combine like terms. So the same variables, you have your x terms and your y terms and your units. So our x terms, we have 1, 2, 3, 4 x terms, 1, 2, 2 y's, and 6 units. So the perimeter of these tiles are 4x plus 2y plus 6. For part B, we have an X tile and we have a unit tile. So for here, the length of this side is X plus 1, and then down here we have plus 1, and plus 1 here. But you don't know the length of this. You do know the length of this tile all the way down is X. Well, you can see that right here, this part bumped out over here. So if we add the length of this plus the length of this is going to equal x, because from here to here is x. And remember, opposite sides of a rectangle are congruent. So if this equals x, the length of this side equals x. So again, this plus this equals x. So we have x plus 1 plus x, the sum of these two, plus 1. And now we're going to go ahead and combine like terms. We have 2 x's and 4 units. So the perimeter of these two tiles, 2x plus 4. For problem 377, we're going to again find the perimeter of the group of these algebra tiles. And remember that opposite sides of a rectangle are congruent. So that means they're equal. So if we have, this is y squared, so we have y multiplied, y times y is y squared. So the length of this is y. But on this side, we don't know the length of this. But we do know that from here to here equals y. So the length of this plus this is going to equal y. And then the same thing that we have over on this xy tile, the length of this is x. So from here, and then this part right here bumped out up to here, so we add these two, and that will equal x. So now we're going to go ahead and take the sum of the length of all the sides, and we have y plus, or we'll just go this way, y plus x plus y plus 1, and then this plus this equals x. Then we have a 1 unit right here, 1 unit here. This plus this is going to equal y, and then we add up all the units, and then we have the length of this side is y. Now we can go ahead and combine like terms, and I'm going to go ahead and put it in alphabetical order. So we're going to do the x terms first. X plus x equals 2x. 1, 2, 3, 4 y's, so plus 4y. 1, 2, 3, 4, 5, 6 units. 377D. Here we have the length of this side is y. And I know from here to here is y. So if I add the length of this plus the length of this is going to equal y, because from right here, this length that's unknown just bumped out over here. So you're going to go ahead and add the sum of the, take the sum of the length of the sides. So 1 plus 1 plus 1 plus x right here plus y, these two sides, plus x plus 1, 1, and 1 plus y. Now we can combine like terms in alphabetical order. X plus x equals 2x, y plus y, 2y, and the units 1, 2, 3, 4, 5, 6, positive 6. So the perimeter equals the length of all the sides, which is 2x plus 2y plus 6. For problem 378, you need to use what you know about slope and y-intercept to graph y equals 1/2 x, negative 1/2 x plus 3. So I notice that this is a negative slope. So when you graph a negative slope, it's going to be sloping towards the negative x's. So it's going to be sloping to the left. If it was a positive slope, it would be sloping towards the positive x's. So this has a negative slope. The b value is the y-intercept, where it crosses or intersects the y-axis. So here's the y-axis. And so this is going to be our starting point at positive 3 on the y-axis. And our slope, rise over run. We can rise 1 and run negative 2. Or you can rise negative 1 and run positive 2. Negative 1, positive 2. Rise negative 1, positive 2. Or, again, rise 1 and then negative 2. Doesn't matter if you do negative 1 and positive 2 or positive 1 then negative 2. Just one of them has to be negative because it's a negative slope. For problem 379, we need to write the equation of the line containing the points in the table. So here in the blue, these were the given points for the table. And we have x and f of x. So the function of x. X is the input, f of x is the output. Think of the output as the y value, input x value. So one way to write the equation, and remember the equation for a linear function is y equals mx plus b. So if f of x represents the y, m represents the slope, b is the y-intercept. And we need to find the slope and the y-intercept. One way of finding the slope from a table is rise over run, delta y over delta x, or the difference of the y's over difference of the x's. Well, the y's are increasing by 1 for every 2 of the x's. 3 minus 2 is 1. 4 minus 2 is 2. And so every time you add 2, 2 plus 2 is 4. 4 plus 2 is 6. It's a constant rate of change. So our slope, or our rate of change, is going to be 1/2. Rise over run. 1 over 2. Now, to find the y-intercept, there's two ways you can do that. One, you can extend the graph when x equals 0, because that is the y-intercept. When x is 0, your y value. So it would be the y-intercept. So I could do 5, 4. So you can see the pattern. We're just subtracting 1. 3 minus 1 is 2. 2 minus 1 is 1. And 4 minus 2, 6 minus 4, 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is 0. So when x is 0, y is 1. That's our y-intercept. It's easy to do when you have a table set up this way, but sometimes it's a fraction, or sometimes it would just take you too long. So the other way to find the y-intercept is once you have the slope, you can plug in any of the values in the table for x and f of x or y. So I chose for x 6. So x equals 6. So I plugged it in. And when x equals 6, f of x equals 4. And now I solve for b. Well, half of 6 is going to be 3. And now I still need to find b. Inverse property of addition is subtraction. Created a 0 pair. 4 minus 3 is 1. So we get b equals 1. So that's what we got here. Our y-intercept. When x is 0, y is 1. Or f of x is 1. So our equation would be in slope-intercept form, f of x equals mx plus b. Our slope is 1/2. Our b, our y-intercept, is 1. This is problem 381, A and B. For A, we need to rotate triangle ABCD 90 degrees counterclockwise about the origin. Well, here's the origin, and I'm going to show you using patty paper. So I'm going to go ahead and put my reference cross at the origin. I trace rectangle ABCD, and I'm going to rotate it 90 degrees counterclockwise. Well, right now, my y-axis is pointing at 12 o'clock, and I need it to rotate counterclockwise a quarter turn to 9 o'clock. So I'm going to go ahead and put my pen here, keep it at the origin, and rotate it counterclockwise, the opposite way a clock moves, 1/4 turn. So now my arrow is pointing where 9 o'clock would be. And here is my rotated image. And if I had written on the back side, I would be able to go ahead and trace those points. And here is my rotated image, rectangle ABCD prime. Don't forget to put the prime marks. If you don't put the prime marks, you don't know which one your pre-image and your image is. For part B, we're going to reflect rectangle ABCD. So we're going back to our original pre-image. So we're not going to reflect ABCD prime. We're going back to our pre-image. And we're going to reflect this across the vertical line x equals 1. So here's the origin, and I go on the x-axis to +1. Well, here's +1 on the x-axis, so here is my line of reflection of x equals 1. So this is the line of reflection, not the y-axis. And if C is 2 units to the left from the line of reflection, C prime would be 2 units to the right. D is 1, 2, 3, 4, 5, 6 units to the left. So D prime, or double prime, is going to be 1, 2, 3, 4, 5, 6. B, good thing I highlighted it. I was going to start from the y-axis, but my line of reflection is x equals 1. 1, 2 units to the left, 1, 2 units to the right. A is going to be 1, 2, 3, 4, 5, 6 units to the left, so A double prime, 1, 2, 3, 4, 5, 6. The reason why we're calling this double prime and not prime is because our first transformation on this graph was this one, rectangle ABCD prime. So since this is our second transformation on the same graph, this is going to be rectangle ABCD double prime.